Hi, this is Haishi. I'm a Windows Azure Technical Evangelist, and this is the first video of the video series what I call Cloud Patterns. The idea of this series is to summarize patterns and solutions to common tasks and scenarios you may face when using Windows Azure Cloud Services. Especially, I want to focus this series on proven practices and common patterns that you can take and apply to your own projects. Today we'll talk about dealing with long-running tasks. In future episodes, probably we'll go into communication patterns, messaging patterns, error handling patterns, fault recovery, failover, or even security, etc. However, what I'm really hoping for here is to create this platform so that you can come out and share your experience and ideas when you deal with typical tasks and scenarios using Windows Azure. We can share the ideas here with a broader audience so we can all benefit from proven patterns when we face similar problems or tasks in our own jobs. I hope this idea makes sense, and let's get started. In this first episode, I'll talk about long-running tasks. Long-running tasks, as the name suggests, take a long time and often quite some resources to complete. They're slow, and they are often the deciding factor of your overall system throughput. So it's very important to have an efficient, scalable, and hopefully simple architecture in place to deal with long-running tasks, instead of patching up your system later on. In this video, I will present three related patterns, and I'll focus on the last one, which is the request acknowledge push pattern. Now let's look at the first pattern, which is the request acknowledge pattern. You can see from this swim lane diagram, it's really simple. This is basically a typical asynchronous pattern. The client creates a request and submits the request to my web role, which is my front end. My web role will create a job and send it to a queue service, and then the web role will acknowledge the submission of the job immediately to the client. So as far as the client concerns, the workflow is done, right? The workflow is between the request and the response. And there's another workflow which runs in the background, where the worker role, which is my background service, pulls the job queue for new jobs, and when it sees a job, it will get the job and process the job. Imagine a scenario that there's an online bookstore, and this is typically where this pattern can be applied to. For instance, when you buy a new book from an online bookstore, your job on the website is done as soon as the order has been submitted to the online store. All you need to do is to wait for the delivery man to show up at your doorway at some later time. Because you know, once you submitted your order, that order will be processed by the online store at some later time. And it's really easy to implement this pattern using Windows Azure Cloud Services. Here, I have a cloud service that contains one web role, which is my front end, and a worker role, which is my back end. The client submits new requests or new jobs through my front end. It's a simple AJAX call to my job controller. And what my job controller does is to create a new message and send the message to the job queue. Then the controller will acknowledge the job submission immediately by returning a job ID. And you can see the client is submitting the job. Then when the acknowledgement comes back, it will just update the UI. And what happens behind the scenes is not important at this point. Basically, the job is submitted to a queue, and that queue will be cleared at some later time. And let's see how it works. Look at the first section, which uses the request acknowledge pattern. If I click on this job, imagine I'm purchasing a book. You can see I got a job acknowledgement, and in many scenarios, this is actually sufficient for the end user. That from the end user's perspective, the workflow is done. There's another separate workflow which runs in the background, but it doesn't interfere with your other tasks. I'm free to move around the UI and do some other things. So I'm not blocked by these long-running tasks. So that's really the simple request acknowledge pattern. But in many cases, after the user submits a job, she wants to know the progress of that job. And to provide the progress, we have to do some tricks. Because as far as the web server concerns, once the response is sent, once the acknowledge is sent back to the client, that request is fulfilled, right? It doesn't have a continuous feedback mechanism to send more information back to the same client. So one way to deal with this is to use the request acknowledged pull pattern. And you can see the top portion of this diagram is the same as the previous one. The difference is here that as the worker processes the job, it will save intermediate results or progress into a database. And the web role will provide additional interface so that the client can pull for updates. So in turn, the web role will query the same database, get the result back, and send updates back to the client. So this is a very simple pattern. Basically, the client submits a job and it starts a timer and keep polling for updates. Let's see how this works in the code. You can see in the second version of the client here, after the client submits a job into the server, the client starts a timer which will poll for job updates every second. And in the polling method, you can see I'm calling into the additional API the server provides, and I'm stopping the timer once the job is complete, which is 100%. And let's see what happens in the background process. So basically here, in the background process, I'm getting the message, which is the job, and I'm simulating a long process. Basically, I'm sleeping for 10 seconds, and on each second, I'm updating the progress by increasing the percentage by 10%. Here you can see I'm not using a database. Instead, I'm using a local cache cluster as my storage. I guess using a cache cluster instead of a real database here makes sense because first, the job states temporal data. I don't really want to preserve them permanently. The second, the cache cluster gives me better performance when I save job states. So that's the little implementation details there. Now let's go back to the PowerPoint and observe this pattern again. This is a very simple pattern and it works under the HTTP protocol. But can we do nicer here? One thing I don't like that much is the additional database piece. wouldn't it be nicer if the worker role can somehow directly report the states back to the client? In this way, we'll get rid of the database layer altogether, and our architecture will be simpler, which leads to the request acknowledge push pattern. You can see in this pattern, again, the first portion is the same as before. And now I've got rid of the database layer. As the worker role processes the job, it will push updates back to the web role, which in turn will send the updates back to the client. And this is quite impossible in the common HTTP request response pattern, because your HTTP request is already completed up here. And how do we create and maintain this channel so it can push updates back to the client? And fortunately, now we have SignalR, which allows us to maintain a two-way communication between the client and the server, and it allows the server to proactively push updates to the client. What we'll do here is to create a SignalR hub on our web role, and the worker role will connect to this hub using a proxy and push updates to the web role, and then the web role will push the updates to the corresponding client. Let's see how this works in the code. Before we go into the implementation, let's first examine our job class. So here you can see I have a very simple job class. And what's special about this class is that I have a client ID embedded in my job class. The client ID records the ID of the client that submits the job at the first place. I need this information because when the web role pushes update to a client, it doesn't want to broadcast the updates to all the clients. Instead, it will send the update to the specific client who initiated the request. So this client ID will help me to close that loop. Now let's see what happens on the client side. You can see the third version of my client is basically the same as the first version of the client. There's no more additional polling going on here. But I do need to connect to the hub, and I'm saying when the hub send me progress update, I will update the UI. And here you can see after I start the hub, I will record the client ID as my current hub ID, and this client ID will be submitted back to the server when I submit the job to the server. Then later on, the server can use the same client ID to trace back to the same client. And on the server side, I'm actually using the exactly same method for all three scenarios. The server just create a new message, send a message, send an acknowledgement, and that's it. The worker role is a little different here in this case. First off, you can see the code of creating and connecting to the hub proxy. And here in my long simulation, instead of pushing the job states into a database or a cache cluster as we did before, we are calling into this proxy and invoke the progress updated method. And let's take a quick look at the hub, which is really simple. And that's the method the worker role will call, and in turn the hub will use the client ID to invoke the client callback, basically, to push the updates back to the client. Now let's see how it works in the sample. You can see in the third part of the UI, I'm using request acknowledge push pattern. And when I click on the button, I submit the job, and I get acknowledgement of the job as before. And then I should see the job states get pushed back through the Signal channel. And just to verify if the updates are indeed pushed back only to the initiating client, I have two client instances running here. And I will submit the job from client A. And then I will submit the job from client B. You can see the two jobs are actually independent. The reason I got this, the job 2 was delayed because there's only one worker role, and which is busy handling the first job. That's all the time I have for this video. However, there are actually many other aspects to discuss about long-running jobs. I wrote a blog article last week, and in that article, I touched upon other topics such as canceling a job, and how to deal with failures, and how to detect and handle duplicated requests, and how to handle different job priorities, and how to keep up the performance when your system is under load. So if you're interested, you can read that blog article, and we'll surely cover some of the topics such as failures and scaling in future episodes. And that's all I have for this session. I hope this helps, and I'm wishing to hearing from you about your patterns and experience using Windows Azure Cloud Services. Thank you for watching, and see you next time.